So let's see this figure. We have here Alice who wants to communicate with Bob. Alice and Bob. They want to. Alice wants to send a frame to Bob. So as we said, we need both link layer addresses and network layer addresses. So you see here, L2 is the link layer address of this node. This is a node and this is a link. So N2 is the link layer address of this node, and N1 L2 is the link layer address of this node, and L1 is the link layer address of this node, and we have N1 the network address of this node, and N8, look, this is N8, not N4. So N8 is the network address of the final node. So as we said, the network layer addressing is not enough for the data frame to go to the destination, because it's only telling you the source and destination addresses, IP addresses. Therefore, we need the link layer addresses. So when we send the frame, Alice sends the frame, it will include, this frame will include L2 and L1. Now, a question. When you send the frame, you know L1 because it's your MAC address, right? As we said, we can check our MAC address from, so you can have this L1, but how you get L2? Who can answer this question? Now let's
The L2 destination, yeah?
Destination, not the final destination, the next node. Let's repeat the question another one. So we have this frame that we want to send. We know our IP address. Here is my IP address, Alice's IP address, and N8 is the destination IP address. So as we said, for example, if this is a website like Google or any website, google.com, when you enter that address in your browser, it's a name, it will be translated into IP address. So you'll get the IP address of the destination using some service which is called domain name service. Will translate the Bob name into his IP address. Okay, so you have your Alice network address and Bob's network address, and you have your link layer address or MAC address, and you need also the next node link layer address. So how you get this? Actually, we have a protocol specialized to do this job. So ARP will get L2 for us before we send this packet or this frame. So we cannot send this until we get this L2, okay? So we'll study ARP in the coming slides. Now, you used ARP to get L2. Now the frame is ready. You send this frame, and then the router will receive it, will do the decapsulation and recapsulation again, encapsulation. So decapsulation up to network layer and encapsulation again. So when you do encapsulation, you can change these things. Okay. Of course, the source and destination IP addresses will stay the same because the source is always Alice, and the destination is always, final destination is Bob. So they will say stay the same here and here, but what will change is the source and destination link layer addresses. So here is here it was, the source was L1, destination L2, but here the source of this is what? L4, and the destination is L5. This is L5 is the link layer or MAC address of this router, of this port of this router. As we said, each device on the network will have a unique link layer address. So at this node, when we send a frame from, when we decapsulate, we remove these here, okay. When we encapsulate again, we'll add this instead of the original ones, okay. So we just in the data link layer, we just deal with these addresses, not the network layer addresses. Now the source is L4, destination is L5, and the IP addresses of the source and destination are the same. Now at this link, when you send from this node to this node, the packet, the frame will be like this. The source is L7 here. Look, this has got 3, for example, a network interface card. Each one will have its link layer address. Okay, so L7 was the source of this, and L8 is the link layer address of this, is the destination of this frame. So this way you can go from Alice to Bob through all the intermediate nodes. So now, as we said, we need a protocol to get this L2 to get this L5, because here when you assemble the packet, you know your MAC address, but you don't know this router's, this port's MAC address. So how you get this, or here, how you get this, how you get this, which is we use a protocol called ARP, Address Resolution Protocol. Anytime a node has an IP datagram to send to another node in a link, so we have node and node, this is a link, we'll need ARP. Always when you send from node to node on a link, you need ARP to resolve the it has the IP address of the receiving node. IP address of next node is not helpful in moving a frame through a link. So if you have the IP of this, it's not enough for you to move the frame from here to here. You need, as we said, the link layer address. We need the link layer address of the next node, or of this L2 in this case, link layer address. This is when the address resolution protocol, we call it ARP, comes into play. So if we look at ARP, ARP actually is, you see, this is network layer, so it's layer 3. ARP is not a layer 2 protocol. ARP is a layer 3 protocol, but it provided services to layer 2. Okay, so we use ARP services in layer 2. So it works actually in layer 3, or the network layer, as we'll study later, the IP and ICMP IG MP, all these are network layer protocols. Now we'll see how ARP operates. Okay, could you please send me your names in chat so that I record it and send me your names in 2 minutes. Okay, let's continue. I'll save chat now if anyone is left. So how ARP works? Let's see how ARP works. Here, this sorry, just sorry. So when we send a request, ARP request, we have two things here: a request and a reply. When we send a request, ARP request, it will be a broadcast. Okay, so we broadcast the ARP request, but the reply will be unicast. So what we mean by broadcast? What we mean by broadcast is that you send it to all other nodes. By unicast, you mean you just send it to a single node, or to the, in this case, the source. Sorry, the source node. So what happens when you send a request? Looking for a link layer address for a node with IP address N2, for example. This system A is looking for the IP address N2. So you need its link layer address. So you send a broadcast. Okay. So who has got N2 here? So this one, because it has got, they will all receive the broadcast request, all of them. But in the request it says who has got N2 network layer address. This has got N4, so it will not reply. This has got N3, it will not reply. But this one has got the N2 network layer address, so it will reply to the request and send its L2 address to the source. So here is a unicast. It only sends to this, not to the other ones. So only this system will receive the unicast reply. Okay, so this is a simple explanation of the ARP request and ARP reply. So we have ARP request, which is broadcasted, and ARP reply, which is unicast. ARP packet hardware type defines the, if we look at the ARP packet, the header, it contains hardware type, which defines the type of the data link protocol. So hardware, I mean, it's Ethernet is given type 1. So if what is the hardware? Is it Ethernet? Is it token ring? Is it whatever hardware? The next field is, so these are bytes, 0 to 16 is the hardware type. 16 to 31 is protocol type, defines the network layer protocol. So if it's IP version 4, this value would be 0800 in hexa. Okay, so this defines the network layer protocol. Now we have source hardware and source protocol address, protocol length, hardware length, defining the link layer and network layer addresses of the sender. Okay, okay, we have the source hardware address, which is what? Before that, we have the operation. We have two operations of ARP, either a request, which is a broadcast, or a reply. So if this one is 1 means a request, if it's 2 means a reply. Now we have the source hardware, which is the MAC address of the source, and the source protocol address and destination. So if you send a request, you don't know the MAC address of the destination. As we said here, when you send a request, you don't know the destination MAC address. You are asking for that address. Okay, so this will be empty. This field will be empty when you first send the request and the destination protocol address. We can use a Wireshark to catch some ARP packets and analyze them. You can install it on your computer. I'll ask you for a homework to do that for this chapter. So you should install ARP, Wireshark, and capture some ARP packets and analyze them. See the source, the destination, both link layer and network layer addresses. Okay, we'll also do some examples for you. This is an explanation of how ARP works. So host A with a network layer N1 and the MAC of L1 has a packet to send to another N2 L2, which is unknown to the first host. Of course, L2 you don't know it. The two hosts are on the same network. So here you know the N2, the network layer address of both the sender and receiver N2, but you don't know L2 because you just started to send the ARP request. So this will be a multicast request. You can here, for example, here you see L1, N1. Here it's empty because you don't know the MAC address of this. It's a request, so you want to know this. Okay, and N2. You send this across this link, and then you'll get a reply. The reply will be, you see, L2, N2, L1, N2. So once you received, you know the MAC address of this because it's here, you see, source link layer address and source IP address, destination link layer address, destination the source IP. This is, I think, wrong. I'll just double check. Okay, so this should be 1. So this is the reply. So from the reply you know L2. Now once you know L2, you can now start sending data from A to B. So if Alice needs to send a datagram to Bob, Alice finds the network layer address of Bob using DNS, as we said. For example, this is Google. So you can use DNS to get the IP address of Google, of any website, of any device using DNS. So if you know the URL, you use DNS to get the IP address. So you have your own IP, you get the IP of the Bob, you know your link layer address, you want the link layer address of Bob, so you use ARP. So here Alice, you see, this is the network layer address and this is the link layer address. Okay, so N for link network and L for link layer address. Okay, so you want to communicate, Alice wants to communicate with Bob. See what happens here. So you have your data from upper layers going to network layer. You use ARP to, you see now, the datagram, NA, network layer. We are in network layer now. You have NA and NB, network layer of the address of the destination. Now at data link layer you need L1 and LA and L1 because you go from node to node, not directly from here to here. So you have to go to this node and then from here to here and then from here to here. So there is a hop to hop, node to node delivery process. So first you go from this node to this node. So you need first the link layer address of this node so that you can do the communication, and then you send it to the node 1, and the process will be repeated until you go to the final destination. So let's see what happens when you send the packet. So you send it now from here to here, okay, to this port. Now it arrived at the router, okay, at the router R1. Router, of course, you needs to decapsulate and then recapsulate. So it received the packet will be decapsulated, okay, and when you send it again, it will be encapsulated again. So as we said, the router is a layer, which layer device? Layer 3 device, which means it can process the up to layer 3 the data. Now this is the link. The router received the data from this port, and then you see from physical layer you go process the headers, okay, the link layer, then the data network layer headers. So it received it like this. When it assembles the packet or the data again, or encapsulate it, it will modify these. You see, this being changed. Okay, here the network will always be the same, source destination. Now you see, when you move the data between these two nodes, you need these addresses, N2 and 3. You don't need any more sorry, I'm just L2 and L3. You don't need LI, L1. So instead of L1, LI, you'll use L2 and L3. L2 is the source, L3 is the destination. Okay, so you send this, and now you have another node to node. So actually here is the final destination, so the final link. So you'll do again. Here you have L4 and LB. So L4 source, LB is but the network is always the same. Okay, so this is the process of ARP. And then at the odd bob, you decapsulate the packet and get your data, original data that Alice sent. This is the process of ARP. Okay, 1 second please.